Welcome to AS Levels Computer Science Lessons, and we are on our chapter number 12 of our paper number 2. Software Development is the name of our chapter. We have discussed about the program development life cycle, and we have
Yes.
discussed about the development of life cycles. Today, we are going to
Mm.
continue with the topic of program design. As in the explanation, I told you that program design is basically the main backbone of a program. Because when we are designing the program, then we come to know how our program look like. Like program design tells us the basic facts of our program, right? So purpose and structure. So what is the first thing in program designing? Of course, when we are going to design our program, the basic thing is a structure chart.
Mm.
Designing, we have flow chart, right? We have a structure chart.
Mm.
So a structure chart is a modeling tool used in program design to decompose a problem into a set of subsets.
Substance.
It means that
Mm.
you are breaking down your program into the steps. Why? To make it more easy to understand. Because when you are decomposing your program, your design, it is become very easy for the others to understand the basic structure of your program. Look, so this is called structure design. This is also called hierarchical diagram. What it called?
Hierarchical diagram.
So in this way, we are going to tell the other people that what are the basic things in our program and how they are breaking down into further steps. This is called subsets. What it called? Subset. Like this is a program. This is the subset of the program.
Mm.
This further subset of your program. This is further subset of your program or subprogram. So this is called
Okay.
subset or subprograms like this.
All right.
So the structure chart shows the hierarchy or structure of a different modules. So you can say this is module 1, this is module 2, this is module 3, this is module 3.1, this is module 3.2, this is module 2.1, this is module 2.1, oh, 2.2, this is module 2.3, and so on. So module means parts.
Okay.
So how they are connect and interact with each other. Yes, with the help of these modules, we can understand
Mm.
that how the subprograms, the subsystems, the subtasks are connected with each other. Each module is represented by a box. So look, I have drawn the box and the parameters. The parameters means the values written inside. So they are formed from the modules are showing by arrows. So these are the arrows. Look, I'm drawing an arrows for you. In this way, the arrows are going to be shown. So the arrows pointing towards the module receiving the parameter. Each level of the structure chart is refinement of the level of. We are refining our
Oh.
system. We are refining our
Mm.
we are refining our designing by making the structure charts.
Okay.
Any confusion?
No, sir.
So you see the figure 12.5 shows a structure chart for converting a what?
Temperature from Fahrenheit to Celsius.
The top level shows the name for the whole task. So this is top level.
Mm.
It shows that we are converting temperature, and that is refined into how many? Three.
3 subparts.
So one, 2, and 3.
Hmm.
Now, how we are representing it? Do you know about these arrows? These arrows, I told you, these arrows are showing you the parameters, right?
Okay.
Are showing you the values of the parameters. So you see this converting temperature. Okay, what we are doing here, input
We are entering the temperature into the
temperature.
system.
Look, the temperature is going to be input. It is showing the parameter. It is going there. Okay, once we input it, what we have to do? Tell me. The temperature which
We will
is Celsius
convert the temperature.
in Celsius.
Yes.
So what happened when you convert it in Celsius? Look, the values are going again. Then we
Hmm.
are going to form an output. So look again, the arrow is with the parameter. So this is a variable. Temperature is a variable parameter. And then we print our output.
सर जो arrow का नाम होता है, the arrow is itself, it's called the parameter.
No, no, no. Arrow is not the parameter. Arrow is showing you the value of the parameter passed from the modules. Temperature is basically the parameter. Temperature
Okay.
is a variable. So with this structure chart, what do you understand?
Say that we take our program and then we create subtasks, and
Uh,
then that
I'm asking what you
subtasks.
understand what is going on in the structure chart.
सिर्फ वो टेम्परेचर हम एंटर करते हैं, it gets converted and then it gets out.
Exactly. It in simple words, you can say, sir, we are converting the Fahrenheit temperature into the Celsius.
Degree Celsius.
That's it. Understand?
Yes, sir.
Okay. Now take out your book, write down the points on a structure chart, and draw this example. Now, you see, there is a bit changing in the structure chart. What is that? The structure chart can also show the selection. What do you mean by selection? Any idea?
Yes, sir. So it means that there can be two options that can be chosen.
Selection. You remember we have done the pseudocodes on selection like if then else. So it
Yes.
means
Yes, 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 yes.
selection. So the temperature conversion task above could be extended to either convert from Fahrenheit to Celsius. So look, we have done it. Fahrenheit to Celsius or Celsius to the Fahrenheit using the diamond-shaped box to show the condition. Yes, we are expert in this thing. That when we are going to use a selection, we know that we have two types of
That,
selection.
yes.
The first one is if then else,
Mm.
and the second one is case of. In
Yes.
case of, if we have a multiple choices, so we use case of. Okay.
Mm.
So you see, convert temperature, input temperature. This is our parameter. So it is showing the
Mm.
parameter. That parameter is going to be input. Once it is input, the parameter is go for the processing. What? Because it is converting from Fahrenheit to Celsius. So here it is converting. After converting the temperature goes back and then it produces output. But what happened if the temperature is not Fahrenheit, but the temperature is in
Celsius.
So what happened? Temperature in Fahrenheit? If it is true, look, if it is true, the temperature is going to be converted into Celsius. But if it is not true, then temperature moves back. And then the temperature, it means must be in Fahrenheit. So it is Fahrenheit. Yes, we have converted it and it moves back here. So it is possible that we are going to apply a choice when we have conversion. So maybe the conversion is from Fahrenheit to Celsius or Celsius to Fahrenheit.
Fahrenheit.
Okay. A structure chart can also show the repetition. The temperature conversion task above could be extended to repeat the conversion until the number 999 is input. Okay. So it means we keep converting the temperature. But
Hmm.
what is thing that repeating again and again? What is that thing called?
Iteration.
Iteration. And iteration means
Loop.
how many types of loops I teach you?
For loop. While loop.
While loop and repeated them. So
Yes, repeat
what
until.
happened when the loop is keep repeating? Definitely we need to stop the loop. So we are going to produce or giving a condition in our program. So I write a condition that keep input the temperature, but until the temperature is 999. So when we input 999, what happened? Our loop will be terminated because the condition is true, 999. So convert temperature, input temperature. So the parameter is going to be input. Then the parameter is going to be processed. The temperature converting to Celsius. Fine, moving on. Then it produces an output. It keeps taking temperature, keeps taking temperature. We need to stop it. So here I'm going to input the temperature 999. As soon the computer receives input temperature 999, it is going to be stopped here.
Okay.
So once a structure chart has been completed, it can be used to drive a pseudocode algorithm. Fine. So what we have to do? Now you have to draw this one with the repetition, sorry, with the selection and draw the diagram as well.
Okay, sir.
Okay, so we have done the activity 12B. Now we have to do, okay. Okay, now we are going to use the pseudocode because after the structure chart, we come to know how our program look like, right? So this is how a possible structure chart here. So you input volume and surface area, and you have given the condition here. What is the condition? Until the radius is 0. So this is a loop. So when you keep repeating the radius again and again, it performs a calculation. But definitely you need to stop it. So you give a loop condition until the radius becomes 0. You need to terminate it, right? Okay, so what are the variables you're going to use? Radius. It stores the radius. Answer, it stores a calculation. And of course, the pi value. The pi value is a constant, not a variable. So declare radius, declare the answer, and constant is a pi 3.42. Now, what you are going to perform, you're going to find out the what? Calculate
The radius.
volume and
We will calculate volume or surface area.
sphere, right? So look, first you need to call the function. Calculate volume. This is the name of our function. What is the data type? The data type is real. This is our parameter. Look, the point is, sir, why we are using the word function here? This is a subroutine. Remember the topic subroutine.
Yes.
So when you are going to make a flow chart, you are going to make the subroutines. And when you're going to make a subroutines, you have to use either function or procedure. We have two types of subroutines, function or procedure. We use function here. We use function here.
But
Okay,
I think that using procedure is easier than functions.
which one?
Procedure.
It's up to you. It's up to you. No problem. If you don't want to return your value, you can use procedure. What is? But if you wanted to return the formula, definitely you have to go for the function. So calculate volume. The parameter is a radius and the data type is a real. And you want to return the value in real. Now, return the formula. What is the formula for the sphere? 4/3 pi
Uh,
cube.
pi r cube.
Pi r cube written is pi r into r into r. Fine. And function, that's it. Now you want to calculate what? The surface area. Again, the
Surface
radius is
area.
a parameter with the data type real and you want it to print in real. So return 4 into pi r squared. This is a surface area. This is a volume formula.
Yes.
Then add the function.
Hmm.
So the input
Okay.
and output modules can be defined as procedures. Now, procedure, input radius.
Hmm.
Now, input radius. While the radius is lesser than 0,
Hmm.
then you are going to print a message on the screen. What is the message?
Please enter a positive number.
Okay, so again, you're going to input the radius and while.
Okay.
So this is a loop.
And
This is a loop.
yes. Okay, understood.
A loop. Then you have to end the procedure output
Hmm.
answer, and end procedure. So up there, you're going to apply the formula, so you use function. But when you're going to use the radius, input radius, and you're going to use a loop, so you have to apply the procedure there. This is
Okay.
the pseudocode we are going to use to find out the sphere, volume, or the surface area. Right? Please start writing this one. You have to write this one as well for the revision, then this one, and then this one.